Imagine Blender but online and multiplayer. I'm building a real-time 3D modeling tool that works entirely in your browser. You can create, move, and edit 3D models collaboratively just like playing in a shared sandbox. I'm a solo developer with a background in Unreal Engine and Blender. In my free time, I love 3D modeling, like buildings, vehicles, and any object from scratch. There's something magical about turning an idea or even just a photo into a 3D model. And it gets even better when it's collaborative. That's why I'm creating an easy-to-use 3D modeling web app made for people to build together in real time. The app currently uses three.js as the 3D engine, HTML for layout, CSS for styling, and JavaScript for functionality. I chose the web because it's accessible to everyone and it's the perfect platform for networking and collaboration. One of the first technical challenges I ran into was the axis orientation. three.js uses Y as the app axis, which makes sense for screens. X and Y are the 2D plane, and Z go out of the screen. But in most 3D modeling tools like Blender, Z is the app axis, which is more natural for modeling. I tried switching three.js to use the app internally and it broke the core systems. So instead, I kept Y up as the engine default and just changed the visual representation to feel like the app. That means swapping axis color and directions so the user experience still feel familiar with other 3D modeling tools. three.js offers two main camera controls: orbit controls, great for viewing models, and trackball controls, which offer more freedom but can be disorienting. Orbit controls use spherical coordinates, but they lock up near the poles. You can't flip past the top or bottom, which is frustrating in a modeling workflow. Trackball controls use quaternion, giving full 360-degree freedom, but they tilt the camera and lose orientation, which can be confusing. So I built my own solution, quaternion orbit controls. It gives full orbit freedom without unwanted tilting. Here's how it works. We split the quaternion into two parts. The first is yaw and the second is pitch. Yaw is calculated by projecting the camera up vector onto the world y-axis. Pitch is calculated using the cross product of the up and forward direction. Then I multiply both quaternion so you can flip around the object like in Blender. For object selection, I implemented ray casting. When you click on an object, it gets selected. Then I attach transform controls so you can move, rotate, or scale it directly in the scene. I'll keep you updated on the progress of the project and share challenges you might find useful. The source code is on GitHub. Link is in the description. I'll launch the live version when stage 1 is ready, so you can try it and give feedback. And if you want to support my full-time development, you can find me on Patreon. Thank you very much for watching, and thank you for all your support.